Um, let's get started. Sorry about last Wednesday. I had family emergency at the time. So anyway, um, I believe we talked about the text time until last time, and to refresh your mind, text time is metronome of your whole factory in just-in-time production system. And making every possible process synchronized with this text time is another story. But anyway, we've covered how we can calculate your text time for your factory. Okay. Pitch is a little variation about text time. You know, the ideal just-in-time production system, you produce one by one. But sometimes one by one production is virtually impossible. You're producing a bolt, okay? Then at least you got to have some kind of a small batch pack. So if you have a text time, it takes about 30 seconds to produce a bolt, but you pass the bolt by a pack of 20 and your pitch is 10 minutes. Okay? Okay. Okay. This is what we call a time frame. Usually, in MLP system, as we do the same simple example case, that MLP, we give the work order daily, which means in your control of manufacturing system is done by daily basis. Okay, for some time, your plan or work order give out weekly, and usually a day consists of 2 shifts of 8 hours, and etc., etc. Basically, the more frequently you control your manufacturing system, the better. The reason why do they don't do the frequent control of the manufacturing system? Basically, if we control our manufacturing system more frequently, take the statues and based on that feedback information, you give out the work order again and again very frequently, which is better theoretically, but virtually it is sometimes impossible. Why? Why this is bad? Frequent work order, frequent control, frequent feedback. Why is bad? Practically.
Because already this is this time taken for this setup. If the order change could be when the machinery which will actually need to set up time more and more.
Okay, think about it. Think about it. You guys are all graduate students. I think you guys have a regular meeting with your advisor, maybe weekly, 1 day per week. This is kind of a weekly work order, right? Do you guys prefer daily meeting with your advisor? How about hourly meeting? Why? Why not? You know, if your advisor give 100 amount of the work for it's a 7 days per week. So 7 amount of work weekly from weekly meeting. But theoretically, it is same. You have the daily meeting with your advisor, and advisor give one amount of the work, right? But why don't you do that? Yeah, practically advisors are too busy. You guys are too busy, and you need some freedom, right? It's a natural. You guys have to keep your own inventory of time at your control, which is exactly same in factory floor. Each workstation managed by a person or worker don't like frequent control, but globally thinking, frequent control is much better. However, it requires additional workload, right? You have to have a meeting and you have to prepare something to report and all this errand. Uh, if if the meeting is getting too frequent, those workload are overwhelming, right? So theoretically, we agree that more frequent meeting is better, but however, practically it is not so good. But you know, if you keep to the tact time or at least a pitch, then it will be practically very good. It's a basic idea. And just-in-time production system put those kind of tact time frequent control or feedback are inherent in their own production system. Okay, you don't explicitly take time to make a report to your manager. It is automatically done if you keep this tact time or pitch time. That's the basic idea. How? I will explain. Okay. Okay. This just-in-time production system are from Japan, Toyota Motor Company, and you know, after World War II, all the manufacturing infrastructure was destroyed, and at that time, United States has the strongest manufacturing industry, and Japanese sent some delegates to United States to learn and see and learn how these U.S. industries are so strong. So they do lots of industry touring, but eventually they are more surprised or inspired by United States supermarket system. Okay, let me ask you once again, have you ever been to supermarket? Of course. Or have you ever been to just a local small store, grocery store? What's the difference? Except the size. What is difference? Or have you ever been to some convenient store? And have you ever put your attention to their special chef system? This is the chef vertically, and the product is located like that. Right? So if a customer take the front one, then the rest of the two automatically comes to the front. and so it eventually becomes like that, right? That's the supermarket. And you know, their chef has specific size, so manager don't have to keep the log. How many inventories do we have? They just know that if you see, well, if there is this amount of the empty space, it is automatically shows their own status of the inventory system. Okay? That's the supermarket system which inspired these Japanese guys. Okay? Okay. Well, so the idea from the U.S. supermarket, but in United States they just applied to supermarket system only. But in Japanese industry, those philosophy are applied to the manufacturing, especially the inventory control system. Okay, basically inventory, we are moving a small amount of inventory here and there, but in order to know how much inventories are there, we have to keep down some information sheet, and which basically requires additional work, non-value added work. By doing this, you can eliminate the work, but everything is automatically done. Basic idea is like this. Last one is really important. Elimination of waste is the key concept in this just-in-time production system. Elimination of non-value added process. And this respect for people is from a Japanese culture. Okay? Okay. And the very complex mixture of these two, elimination of waste and respect of people, are now the Japanese philosophy of just-in-time production system. Yep.
So, what do you mean by
Respect for people. It's like this. Think of the very long conveyor belt assembly system and workers doing their own job. Some specific workers are given their job. They are, like a machine. They have to do their own work. That's one thing. The other thing, nowadays, there is okay, before that, let's say like this, if those assembly line stops, it is huge thing. It's effect to the economy and their production and productivity. It's a very huge. But nowadays, the authority to stop the assembly line, whole assembly line, every worker can stop the assembly line. Why? Naturally thinking, it is not so good to give that much of authority to the lower level in management, lower level workers, floor workers. So they don't have any control over it. They just have to do what they are told to do. That's the one thing. But the other thing is, if you respect for people, they give authority, some freedom to make their own improvement. So in nowadays, especially from this just-in-time production system, they heavily rely on the quality circle and the motivated involvement of every workers. So in nowadays, if you go to the factory touring, they have some quality circle managed by some manager, and they put together the ideas how to improve things or something like that. How to, or in another word, how to eliminate more waste or something. That's a kind of respect for people. And this one is actually not stated by the Japanese researchers. The story is like that. Japanese industry was, after World War II, they learned something from US supermarket system, and after that, the competitive power or competitive strength of the Japanese industry are roaring compared to US industry. And now these US guys are just curious why these guys are doing so better than us. So they give some delegates back to the Japanese industry, and they make some kind of report. And those report is the book I recommended in the syllabus, The Machine That Changed the World. So MIT researcher write that work. Among that delegates, there are MIT researchers, and this MIT researcher observed their counterpart in Japan, and respect for people is their result of the observation, as well as elimination of waste. Are you familiar with the Japanese culture? Not really? Okay, it's very hard to explain, but they, unlike Western culture, they do not consider their assembly line worker as just machine or a small part of the whole system. In Western world, they just regard you guys, because you have some limited skills and education, your job is this, and you're just okay to do just what you are supposed to do. That's it. That's the Western. But in Japanese, as well as many Oriental country, we don't think like this, right? Okay, let me explain further. Okay, Taichi Ono is the name of a people at Toyota Motor Company. He's the father of this just-in-time production philosophy, and he's the one of the guy in the delegates, and inspired by American-style supermarket. Okay, basic line is this: each workstation acquire the just right amount of material at just right time, like supermarket. Okay, you pick just what you want. You don't have to keep big inventory. Okay. So each workstation acquire the required material from upstream workstation. Upstream workstation means my former workstation, precisely as needed or just in time. Also, this idea are merged with Toyota Sakichi, the founder of Toyota. Did I explain about the automatic error detection machine? No? In clothing machine? Oh yeah, that's his idea, yeah. Automated so that one worker can operate many machines, or in another word, foolproof philosophy. Foolproof means you cannot do wrong. Okay? Okay. Have you ever experienced about a foolproof mechanism or a foolproof something? Foolproof. There are many. Foolproof. You know, in real world, there are many product or things or stuffs and tools and many other things. And for some tools or product, people are supposed to use the product as it is designed, right? For example, knife, cutting knife. If you use it wrongfully, then it will be a disaster, right? But think about children's toy. Children, I know you don't have any, there are no guys here. Are you married? Okay, not married, everybody's single, no children, so, but you may have some nieces and nephews, and you know how children play. If you give a toy to children, they are not playing with that toy as it is directed in their, manual, right? You know what I mean? But even though the children play with their toy not as directed, those toys should not hurt the children. It's a kind of foolproof design. Do you know what I mean? Foolproof. Okay. You know, in many assembly line, workers pick two parts and put together to make a assembly product, intermediate product. If it is not well designed, for example, if this product is assembled to this hole, but proper direction is this way, but it is very hard to identify this direction or that direction. Okay, so if the worker make errors, so if put it like this, it will be a defect product, which will be scrapped away. Okay, but if you design a new product, this is correct direction, so you can insert it. But if this is the incorrect direction, this cannot be inserted, no matter what. Can you design the product like this? Yeah, that's a foolproof design. Virtually, the worker cannot make any mistake in doing their job. You need to think before, but it is possible. Okay? By changing a shape or something like that. The very famous design of is thing. There is a hole in a part, and there is some cylinder, and you have to insert it, but the orientation should match exactly. Then the foolproof design is if you make this shape of hole and matching shape of the cylinder, then there is no way to misalign it, right? This is a kind of foolproof design. Okay? By applying this kind of philosophy, we can basically eliminate waste. What kind of waste? Misassembled product is also waste, and the worker's time to make that specific misaligned product is also wasted. right? Okay. Any question about foolproof design? Okay. Okay, just-in-time is an integrated set of activities achieve high volume production using minimal inventories, like this supermarket system, raw material and working process and everything else are just in time. Part arrives at the next station just in time. And how can you do this? By eliminating the waste. Okay. Inventory sitting there doing nothing is waste, right? Okay, it's some Japanese term. So in order to understand how this just-in-time are actually implemented, you got to get familiar with some terminology used in this field. Kanban, Jidoka, Andon, Kaizen, Pokayok, Haijunke. As you can guess, it's Japanese. Kanban means visual card. In Korean, we call it 간판. Okay? Jidoka is automation. In Korean, 자동화. Andon is this, paper lantern. Kaizen is improvement, continuous improvement. In Korean, we call it 개선. 포카욕, foolproofing. 하이준케, 평준화 in Korean, or labeling. It's a key characteristic of this just-in-time production system. Okay, so if you visit the shipyard, you did. Sorry for you guys. It's national security. Have you ever noticed any kanban? Have you ever noticed about paper lantern? Okay. Have you been to Home Plus? Okay. What? Lantern. In checkout line, there is a lantern, which is usually this. I think you guys noticed that. 3 colors. Green, yellow, red. When the machine is correctly working, it's a green. If something is wrong, it's a yellow. If everything is not out of order, it's a red. The idea is like this. The state of the machine should be well notified, because if the machine is not working correctly, but the machine's state is not known to the worker, then worker will keep work with that machine, which will end up in something defect product, which is a waste, right? It's 안 돼. Okay. Nowadays, in many factories, if there is some complex machine, everything usually has this kind of ender. Okay, it's on the assembly line, it's on some robotic machine, it's on everything, almost everything. Okay. Okay, visual card means many things. It's also same thing as showing your current state very easily. Okay, have you ever been to Japan? No? Okay. I've been to Japan several times, usually and I noticed this kind of Kanban everywhere. And the most interesting thing was Kanban, wear by a worker in duty-free shop at the airport. A lady at the duty-free shop has some kind of Kanban. Her name and her shift and her all information are written on there in Japanese. But in my eyes, that was Kanban. Okay, giving the information. Also, Kanban work as some kind of inventory information system. Okay, let me explain in later. Sorry. Okay, that's end on. Okay. Definition of waste. Something that does not add any value. Product, inventory, wasted time, and wasted money. The important thing is that this waste is not the root cause. Waste is the symptom. And if you see something is wasted, time is wasted, or inventory, if there is too much inventory, or if there is too many something which do not add any value, then it's a symptom. It points out something is wrong in the production system. Okay, there are waste in operations. Overproduction is waste, right? Waiting time, doing nothing, also waste. Transportation is waste. Inventory, too much inventory, it's waste. Okay, there are many types of waste. There could be a waste of motion, and product defect is also waste. Okay, how can we minimize waste? It's a very simple factory design. There is a heat treat machine here, which is a very expensive and heavy and bulky. So there is a sewing department, grinder department, lathe department, press department, and this one explains the flow of the part. It's a normal, easily seen factory. And reorganizing your machine. And you can think of group technology like this, and also it reduces the waste. What kind of waste it reduces? Non-value added material handling. Compare it. Okay? Okay. Defect is also waste, right? So at the first observation, it could be non-efficient, but this saves money and time and everything. Quality. High quality is the way to minimize the waste. Okay? Self-inspection, it's a normal practice nowadays. Automated inspection, line stopping, empowerment, all these things are what we call quality at the source, and this is one characteristic of this just-in-time production system. Okay. Workers are supposed to work on their workspaces, and after that they are supposed to inspect by themselves. Okay, very straightforward. Working and inspection. Well, inspection is added. Inspection takes some time and cost. So it could be at first look a waste of something. It will increase the cycle time, but eventually it will save much money because, I will give you a very dramatic example. Okay, it's not the case in real world, but let's assume that if there is something wrong in final product, the assembled four-door sedan and F Sonata, let's assume if you see any defect in the part, we have to scrap all the car. Okay? So, well, at the end of the assembly line, we just find out a little lamp on the headlight are gone. Okay? So, have to scrap this $20,000 of sedan. It's a big loss. But self-inspection, before assemble those little lamp, which will save great money, right? Okay. Automated inspection is also very important. And line stopping empowerment is the expansion of this idea. Even though line is very, very big thing. Stopping the line at the factory is a really, really big thing. But empowering floor worker to stop the line will save eventually much money, because they do not produce any defect product, which is a waste. Okay. Bottom line, just in time, produce what is needed, when is needed, and nothing else. I just said about Haijunka labeling, uniform plant loading. Workload labeling is really important. Okay? This high fluctuation of workload could easily lead to the waste, overcapacity or too much workload compared to the current capacity. So many delayed things also a waste. So maintaining a stable mix of product is really important. And all these things are the characteristic of this just-in-time production. It is philosophy, not formula or not algorithm or methodology. It's a philosophy and full system, and it does not push things and give orders, and it actually attacks the waste and expose problems and bottlenecks and achieve streamlined production. Okay, it's a management philosophy. So many non-engineering background people from management or from many other fields, people know about this just-in-time production system. Usually, this just-in-time is well implemented by higher-ranking officers, and it's a pull system like this. Supermarket doesn't push things to the customer. Customer pull what they need and when they need. Okay? And the idea is attack the waste and eliminate that waste and expose problem like end-on and other things. Think of it. If you feel sick and you will go visit doctor, right? And when we meet doctor, we describe how we don't feel about ourselves. Well, we have fevers or some stomach ache or something like that. We expose our problem to doctor. Without it, doctor cannot cure us, right? Yeah, it's very straightforward. Go to the doctor and, oh, you are a very famous doctor and fix me. That doesn't work. Which is exactly same in manufacturing system. In order to fix something is wrong, you have to expose it. The idea of end-on is like that. Okay? Why do this just-in-time production doesn't like inventory, the pile of inventory? Well, one thing is it is waste, money sitting there doing nothing. And the other thing is if you have a lot of inventory, it absorbs many problems. Okay? Think about it. If, well, this Japanese earthquake and tsunami disaster, the factory is destroyed, but if they have huge amount of final product inventory, then the actual customer cannot feel about their problem because there is nothing wrong getting their product when they need. Okay? Think about this thing as happening in one factory. If something is wrong, but that workstation has a huge amount of inventory, the problem of that workstation cannot be exposed. Okay? Inventory tends to cover many problems, which is in some sense good, which is in some sense very bad. But idea of this just-in-time production system is expose everything as we go to the doctor. And those problems, their philosophy, according to their philosophy, those problems are originated by waste and attack the waste and make everything very lean and streamlined. That's it. So another terminology for this just-in-time production is lean manufacturing or lean production. Lean. Okay, since it's a philosophy, we cannot purchase a big machine which will do just in time for us. It's a philosophy, so we need employee participation, industrial engineering or continuous improvement, Kaizen, TQM, and other things. Okay, think about this, the theory of constraint. You identify the bottleneck, right? So you do something to improve the bottleneck. Then eventually bottleneck becomes non-bottleneck process and another product, another workstation becomes the bottleneck, right? When the bottleneck does not disappear, it moves. So as long as there is a bottleneck, we have to do some improvement. In that sense, same as in just-in-time, continuous improvement, Kaizen means that thing. Okay. Dr. Owner's observation is the worst culprit of this waste is inventory. Inventory tends to cover all the problems. And this primary driver of waste is variability. The reason people keep the inventory is basically they want to absorb variability. Okay. The other thing is push type of planning and production. Okay. Questions so far? Now it's time to explain about Kanban system. Kanban means a little sign, panel, display panel or something. And in just-in-time production system, they show the information about the inventory, basically. I think it's like that. In MRP system, let's assume here's the first stage, second, third, fourth stages. So some part flows here, and Minseok is doing some process, and the part should be passed to him and you. Okay, let's say this 4 workstation as a factory. In MRP system, we give order to you and you directly, right? You start this kind of work at that time. Same thing. That's MRP system. And in MRP system, you guys are evaluated by how well you keep the schedule, right? So you are trying your best to keep the schedule. Your schedule is you are supposed to do this much amount of work at this given this specific amount of time. That's it. Among you guys, inventory could accumulate or not, but that does not matter at all. As long as you keep the schedule, you're good. That's MRP system. Okay? In that system, if every workstation usually don't have same cycle time, so inventory eventually will happen. Okay, that's one thing. The other thing, in just-in-time production system, you're the final workstation, and you know the takt time, customer demand per given time. So based on your takt time, you are supposed to make one product per 10 minutes, right? That's it. You don't have any work order from control tower. Okay? In order to make a product per 10 minutes, you need input. And you ask him, give me one part, by giving him a Kanban. I need one part. And if you receive a Kanban, then you give the product to your downstream. Okay? Right? And in order to give the product to the downstream, you need one thing from Songpil. So you give Kanban to him. And you receive the Kanban, then now you know you are supposed to begin your work. Same thing and same thing and same thing. Okay? If we stop the work, you don't have to work at all. Because you don't get any Kanban. Kanban is kind of work order, the signal from based on you produce or do the work. Control tower of the factory only controls that workstation. No direct control needed. Because of that, there is no inventory between you guys. Just in time. Okay? Let me explain this Kanban system in YouTube. Mm. Uh, Workstations. It's a virtual factory. You see this empty space actually giving you visual signal. We need to begin the production at workstation there. That's Kanban. You can give the card, you can give the empty container, something like that. Those empty one also work as Kanban and triggers work order your upstream. And again and again and again, that's it. It's exactly same like this. Let's say this is Mohammed. You know text time. You know take time, so you know how much to produce in given time. And this is the chef in supermarket. As I explained, if one thing is moved, it will become automatically like that, and one empty space, it's a visual signal to upstream process. And if you see this visual signal which triggers your work, well, those chefs are supposed to fill that chef with 4 products always, or sometimes 1 product, 2 products, depends on what your pitch is, pack size is. So if you see one, you begin to work to fill this one. This empty space works as visual signal. This is Kanban in supermarket. Or without the chef, you can actually give some empty container. And if you see the empty container, well, I'm supposed to fill that container. It's also a visual signal which triggers your work. And again, that's a pull system. The reason pull is this is his customer. This is his customer. Customer always pull what they just as needed and just when they need it. Okay? That's the Kanban. Question about Kanban? Yes.
We actually considering the tech time.
Yep.
So if we are actually the workstation, so we don't totally consider any type of time within the.
Okay. Designing a factory is different thing. We just assume that you guys are well designed to, you can always keep the tech time with your capability. That's assumed. So in order to design a new factory, you have to think about tech time first, and then check that each workstation can make this tech time or not. Yeah. Okay. Okay. Kanban system is very important to you. You really understand the Kanban system. So I will ask a question. Other than supermarket, have you ever seen the Kanban system working in your own experience? Inventory sheet. Well, probably. There are many other types of Kanban. So, yes.
So printing machines.
vending machine.
Yeah, barrel vending machine. Like, whenever actually customer actually buys one burger, the next burger actually comes.
Yes, that's one part of here, right? That's good observation. Have you ever seen some series of this pull system working?
As you go the restaurant, if the food is
Yeah. Burger King there. You've been to Burger King, and they do not actually, when they are really, really busy, they do not actually begin making the burger after they given the order. There is a little tray of burgers, Big Mac, cheeseburger, chicken burger, fish fillet, and they tend to feel those kind of things. Okay, what else? What else?
the restaurant cafe, and we order some food,
Mm-hmm.
and then we order the manager takes some order, and they order make some food.
Yeah, they put the printed sheet of a little paper. Its order is written on that and give it to the kitchen, right? Pull system. Okay, that's true. And anything else? Some more long series of pulling system. Not really. Okay, you guys been to the shipyard? Have you ever noticed? No? What kind of?
Here, if the waiter is welding
Mm-hmm.
and they order how much they need, and then purchase part, and then describe and rotate the thing, and then purchase.
Okay, okay. Everybody understand what he's meaning? Um, there are many consumables in factory, and they usually put a new can of the welding stick are actually winded in big can, and those welding stick are connected to a welding machine and constantly working. And right after it, there is a unopened new cans waiting there. So once it is used, the worker there just replace it. And if you don't see any new welding can waiting to be used, it's a visual sign to replenish those new welding sticks. Those kind of systems are very much common in shipyard. Okay. Okay. This is really famous picture in just-in-time production system. This is water and there are many problems of stone, such as machine downtime, scrap, inventory, something. Lots of problems commonly found in manufacturing field. And this water level is analogy of your inventory level. If your water level is high, the stone is just submerged and nobody can notice the problem. If the inventory level, water level go down and down and down and down, problem appears like this. And the idea, the philosophy of this just-in-time is reduce the water level. And if you reduce at this much, one stone appeared. Then you do something to eliminate those kind of problem. Continuous improvement. Okay, reducing the inventory level this much, you see machine downtime problem. Now with something and some effort, you eliminated this machine downtime problem. Then now you don't see any problem. The next step is reduce inventory level a little bit further and further to see another problem. The next will be a scrap problem or something like that. Doing this again and again and again, it's what we call Kaizen, continuous improvement. Okay. Question? Yep.
How are different from push production and pull production?
Push production and pull production. Okay, very good. Basically, it's about who is giving you work order. In push production system, main control tower give you the work order. Begin the work at some time with this amount. That's given from control tower or planning department. In full production system, it's a customer who gives you the order. This guy getting work order from his customer, which is this process. Your next workstation is your customer. Okay? So, for some reason, this guy does not consume the inventory, then this guy has to stop the work, right? Because customer doesn't want. But in push production system, there is no direct relationship between this guy's work progress and this guy's work progress. Because control tower gives its order here and there independently. So all you have to do is keep the schedule. You guys to produce 10 parts a day. Then if you do, that's okay. But if this guy has some problem, so cannot consume 10 product, then there will be 10 inventory sitting there. Okay, that's it. Kanban is the visual sign from your customer to you. If you see the Kanban, you are supposed to begin work. Okay? Question about Kanban? I strongly recommend you to search with Kanban in YouTube. There are many nice video clips there. So some illustration videos are there. Also, there are a real Kanban system. Some Kanban is actually a sign a little paper card, and some Kanban is golf balls, and some Kanban is just empty space at the factory. There are many types of Kanban there. Question about Kanban? If this is the shape, the empty space is Kanban. Or if your product is huge, the empty, some parking lot sign kind of visual signal is Kanban. If this is, if your okay. Let me introduce. Have you ever been to what's the English? 회전 초밥. Have you ever been to some Japanese sushi restaurant with a little conveyor belt flowing through,
But actually, I have seen tables that the table contains counter with train.
Conveyor belt are flowing around the shafts, and actually there are two plates. Okay, the price of food are different from color or shape of that plate. So customer are just free to pick what they want, one by one. Okay, and they are charged based on this empty number of plates, right? By the color, by the number, right? Okay, that's a customer side. But these chefs are supposed to fill. How do they know? Well, 2 layers of plate. Blue plate, blue plate. Customer pick first plate with food. If the chef see empty blue plate, they are supposed to fill those blue plate with food with blue plate. That's Kanban. Okay. And I actually see some real factory use a golf ball with different colors. So when they make the downstream workstation producing something and they need some more part, they just put some specific color of golf ball, and it automatically rolls out to this, and if they see the golf ball, then they supply those new part to there with that golf ball. Okay? And one more thing. Chef. Even though we are using the chef, it's up to you, up to us. We can always keep 4 unit, 3 unit, 2 unit, or 1 unit on this chef, right? If this is designed to hold 4 unit, the downstream workstation take one is empty. This visual signal triggers the upstream workstation to fill that one, right? But this 3 is also some kind of inventory, like this, right? It's an inventory. So what they do is like this. People keep the same number of Kanban card, same with number of inventory they want to keep. Okay? And when the production is going well without any problem, they remove 1 Kanban card, which eventually remove inventory between these two process by 1. It's exactly same. We agreed to keep 4 parts at the shop. When production is very good, we now reduce the length of the shop. So now 3 is the full capacity of this shop. It's a reducible inventory by 1, right? And if you reduce the inventory, some problem will appear. And if you solve that problem, you reduce the shape size and eventually by 1 until it reaches 1, the smallest possible inventory. It's continuous improvement by reducing the kanban, number of kanbans. Okay? Okay, it takes some more time, so did I hand out the just-in-time reading assignment? Did you read? Okay. No? Did I hand out the reading assignment on just-in-time? No? No? Yeah, Toyota Motor Manufacturing. Yeah, okay. Did you read? Okay. Okay, let's call it a day because time is up. I will continue about this just-in-time production a little bit, and we'll go to this software tutorial after that. But before that, let's make it sure. Makeup class will be on next Monday from TA, from 5 to 6, 6:30, or 6 to 7:30. Okay, so from 6 to 7:30. Is that okay? Next Monday. Okay. Dinner will be served. Pizza will be served during the class. Okay? Okay. Thank you, guys.